this is how you write standard form into vertex form. Okay, so we want vertex form, which looks like this. It's what you guys are used to. It's what we've been using to graph our quadratics. And now we're looking at standard form, and we have to change that into vertex form. And so standard form has this form right here. It says ax squared plus bx plus c, where the a equals 1, the b equals -2, and the c equals 1, which actually doesn't mean much to you right now, okay? But we can use this stuff later to find shortcuts. Instead, we've been using a vertex form, which has the a, the h, and the k. And so what we got to do is we got to take the standard form, which is right here, and then we have to complete the square for our x terms. So what we're trying to do is we're trying to make a perfect square. It's just so that we can get the form like this, because that's what this means. This right here, this power makes this into a perfect square polynomial. So let's make this part of our polynomial perfect. Now, I'm going to add something to it, but if I add something to it, I also have to take it away in order to not change the quadratic. So when I look at this -2, what I do is I take the 2, I ignore the negative, I take the 2, I divide it by 2, and then I square it. 2 divided by 2 is 1, and then when I square it, I get 1. So I would add 1 and take 1 away in order to complete the square for this polynomial expression or polynomial function. So now I can take this part of the polynomial and factor it. And when I factor it, I get x minus 1 times x minus 1, which we write as x minus 1 squared. Then I have to simplify this part right here, which is 1 minus 1, which we know to be 0, which we normally don't write. But now we have the vertex form. So we can say what A is, we can say what H is, and we can say what K is. So I can see that A is 1 because A is multiplying to the parenthesis, as we see in this form, and he's invisible. H is 1 because it says minus H, and so I see a minus H right here, so H is 1, and K is 0. Now let's graph it just for funsies. You don't have to do this for these problems, but I'm going to do it anyways because you guys have to know this for other types of problems. So the first thing we do is we graph our vertex. We see the minus 1, so we move to the right 1, and I see a plus 0, so we don't move it up or down. Then I can graph my parabola like so. I can pick other points and plug them in. And now we can also identify the vertex. The vertex for this one is 1, 0. Okay, so right there. And you can see the 1 and the 0 with the H and the K. Our axis of symmetry is the line that goes right down the center of the parabola. In this case is x equals 1. And then we have the minimum y value. In this one, we have a minimum y value. We don't have a maximum y value. And that's because the parabola opens upwards. And that's going to be 0. And then we have our y-intercept. Our y-intercept is the easiest point to find aside from the axis of symmetry point. Because in order to find the y-intercept, all you have to do is plug in 0 to the x. So if you plug in a 0 to the x right here or right here, if you plug a 0 into this x, you can see that you get 1 really quickly. And so my y-intercept point looks like that. On the next video, I'm going to show you guys how to do this one. And this one's different because it has a negative in front of the x squared. Instead of having a positive one, it has a negative one.